In this video, we are going to study the distribution of sample means. If you recall, in the previous video, we looked at sample proportions, but now we're going to look at sample means. So for an example, assume that weights of adult males are normally distributed with a mean of 175 pounds and a standard deviation of 35 pounds. A researcher takes repeated random samples of 40 men and calculates the mean of their weights. His first sample has a mean of 182 pounds and a standard deviation of 32 pounds. So before we move on, let's just do a quick warm-up and make sure that we understand all the notation and terminology. So the first question I have is, what is the population in this case? And the population would be adult males. Okay, so this is our population that we're studying, that we're interested in. Now, is 175, is that a parameter or a statistic? So this would be a parameter because it describes a population, and that population is the adult males. So the correct notation would be mu is equal to 175 pounds. And what about 35? Well, 35 pounds, that is the standard deviation for the weights of the adult male. So this is also a parameter. And the notation we use would be sigma equal 35 pounds. So that is also a parameter. And just to finish things off, the 40 men, each time the researcher selects 40 men, that is, of course, our sample, it says right there. And 182, is that a statistic or a parameter? Well, that was calculated from a sample, so this is actually a statistic. And the correct notation is X bar is equal to 182 pounds. And over here, this is also a statistic because it is calculated from a sample, from the sample of 40 men. It's the standard deviation, and we use the notation S equal 32 pounds. Okay, so the first question is, so we had this researcher, if you recall, and he was taking repeated samples, random samples of 40 men, and then he would calculate the mean of their weights, and then he would take another sample of 40 men, and he would calculate the weight. So we are interested in how are these sample means distributed? What is the distribution of these sample means? So the first question is just asking you, in this example, what is meant by the distribution of sample means, also known as the sampling distribution of X bar. And all we mean is that it is the distribution of the values of all sample means, denoted X bar, if we take repeated samples of size 40. So if this researcher could, take every single sample possible of the 40 males in the population, and he could calculate all those sample means, and look at the distribution of all the sample means, that would be the sampling distribution of X bar, or another name is distribution of sample means. The next question we have in part B is a normal model a good fit for the distribution of the sample means in this example? Okay, so in this case, the answer is yes, and the reason is that the sample size is 40, which is large, okay? It's greater than 30, so the central limit theorem tells us that the distribution of sample means is normal. Now, if, the sample size was not so large, like it was 20 or 22, then we can't use the central limit theorem in this condition with the central limit theorem. However, if the original population is normally distributed, then we can still say that the distribution of sample means is normally distributed. So in this case, weight is usually assumed to be normally distributed. So we could probably use the assume that the distribution of sample means is normal, even if we didn't have this condition. For part C, what is the mean in the standard deviation of the distribution of the sample means? Round your final answer to 2 decimal places. So it is known that the mean, the notation for the mean of the sample means is given by mu sub x bar. And it is known that this is just the same as the population mean, which makes sense. Okay, so the mean weight of the adult males is 175 pounds, and the mean of the sample means is also 175 pounds. The standard deviation, the notation we use is sigma sub x bar. Okay, this is equal to sigma over the square root of n. So in this case, sigma for us was, I believe, 35. And here we have the square root of 40. So this is equal to 5.53398. Okay, and since I'm rounding to 2 decimal places, I'm just going to, I don't really have to go further than that digit. It's approximately 5.53 pounds. And just remember, if you were going to round in this calculation, so I just entered this whole thing into my calculator, but if you were going to round, I would recommend being very careful. And if you were, say, going to round the square root of 40, just to be on the safe side, I would make sure to go out, 6 decimal places. So maybe I would use 324. 555. It will just be a good habit for our quizzes and tests. Whenever you're gonna you round a fraction or a square root or anything in the middle of your calculation, remember that the error can get compounded. So always just be on the safe side and use a lot of decimal places. So in part D, it says since the sampling distribution of x bar has a normal distribution, we can apply the standard deviation rule. So the question we want to answer is, for any randomly selected sample of 40 adult males, there is a 95% chance that the sample mean will fall between which 2 values? Okay, so we know that, so if this is the sampling distribution of my sample means, we know that the mean is 175. And we know that 95% of the values lie within 2 standard deviations of the mean. That's for normally distributed data, and that's from the standard deviation rule. We need to figure out what this value is, okay? Adding 2 standard deviations to the mean and subtracting 2 standard deviations from the mean. And so that's what we have to find out. Okay, and now I'm just going to figure out write down the formula for the standard deviation of the sampling distributions. Which we've already seen, but I do want to avoid rounding, so I am going to write everything out. Okay, and now I would normally just punch this whole thing into my calculator, and I get 163.932, and I'm going to stop there since I'm only asked to go out to 2 decimal places. And the other value is 186.067. Okay, so if I round to 2 decimal places, I get 163.93 pounds and 186.07 pounds. Okay, so just to recap, this tells me that there is a 95% chance the sample mean falls in the interval 163.93 and 186.07. One last thing I wanted to say is that if you wanted to if you couldn't punch this whole thing into your calculator, just make sure that with the root 40 you go out enough decimal places, you know, at least 6 decimal places, just to be on the safe side. Okay, so here is the last example I want to do, part E. So we have a group of 40 adult males who would like to ride in a boat that can safely carry 7,440 pounds. In other words, the boat can safely carry the 40 males if their mean weight is less than or equal to 186 pounds. So that's just because 186 times 40 gives me 7,440 pounds. So as long as the mean weight of the males is less than or equal to 186, they should not overload this boat. The question is, what is the probability a randomly selected group of 40 males overloads the boat? So we are looking for the probability that X bar is greater than 186 pounds. Okay, so note this is the sample mean. It is not just X. So this is not an individual male. Okay. I also want to point out that I could use greater than or equal here as well. It's a continuous distribution, so it won't make a difference in the probability. And this is equal to the probability the z-score is greater than 186 minus 175 over 35 divided by root 40. And you might be wondering what this represents. The quantity I just wrote down, this is the z-score of 186 in the distribution of sample means. So this is equivalent to X bar minus the mean of the sample means divided by the standard deviation of the sample means. And we've already learned that the mean of the sample means is equal to the population mean, and the standard deviation is equal to the standard deviation of the original population divided by the square root of n. Okay, so this is just the z-score in the distribution of sample means. I did the calculation, and this comes out to be about 1.987. It's a z-score, so I am going to round to just 2 decimal places since I plan on using the table. You can use technology also. And using symmetry, this is equal to the probability that the z-score is less than negative 1.99. And let's use the normal table. So here we are in the negative z-scores for the normal table. And we are looking for the area to the left of negative 1.99. So I find my z-scores out here. And the 9 is over here. So we're going to look for the intersection. And that gives me 0.0233. So we have 0.0233. So there's about a 2.3% chance they overload the boat. So the last question is, in your opinion, is this boat safe? So there's a 2.3% chance they will overload the boat. That's less than 5%. So you might say, Yeah, that's not too that won't occur too frequently. But it also depends on how dangerous the situation is. So if this was on a lake in the summer and everyone had life jackets, maybe 5% is a good threshold, and you could say, okay, 2.3% isn't that, dangerous. But if you were going whale watching in the Pacific Ocean, off the coast of San Francisco, where the water is really cold, I would probably say I wouldn't want to risk the 2.3%. 1% would be a safer threshold. Probably much less than 1% if it was in the Pacific. But again, it's sort of subjective what your threshold is. 5%, 1%, maybe you want the risk to be like 0.000001.